Alright, we're going to start off with trig. So before we get into the more complicated or more complex trigonometry, we need to start off with the basics. So first thing we need to do is talk about angles. So what is an angle? Remember, an angle is formed by two rays or line segments that share the same vertex. Now I have a picture below, and there's going to be two vocabulary terms that we need to make sure that we understand. The first one is where your angle starts, so that bottom side. We're going to refer to that as our initial side. And then where your angle stops, that's going to be called the terminal side. Very easy and basically common sense, but those terms will come up quite a bit. Now that we talked about the definition of an angle, let's discuss how an angle can be measured. An angle can be measured two different ways. The first way is in degrees. The second way is what we call a radian measure. And this is a little bit more scientific. You'll typically see it if you're taking physics, maybe in physics, higher level math, or higher level science classes. Before we go any further, let's talk about two vocabulary terms that you should have seen in geometry. The first, remember, if the sum of the measures of two positive angles is 90 degrees, the angles are referred to as complementary angles. Now, if they add up to 180 degrees, remember we refer to those as supplements or supplementary angles. So the first thing I want you to do is go ahead and find the complement and the supplement of 54 degrees. Alright, now that we have the basics out of the way, let's talk about what is a radian. Okay, this is a little longer definition, so I'll give you time to copy it down. 1 radian equals the measure of the central angles whose intercepted arc is equal in length to the radius. So what does that exactly mean? So if I have this circle, let's say I'm at the center of the circle and I draw the radius, so that's my R. Let's say we form an angle, so that means I need to draw another radius. So that's also R. This arc right here, I'm trying to highlight it in blue. If that blue arc is equal in length to the radius, then this angle right here, that's going to be considered 1 radian. So that angle measure is considered to be 1 radian. So again, when your arc, so when my length of my arc and the radius are equal to one another, the angle that is formed is considered to be 1 radian. Now, really what's important about this is we need to know how many radians and how many degrees are in a circle. Hopefully everybody knows by now that there's 360 degrees in a circle. Now, how many radians are there? There are going to be 2 pi radians. We will do a short activity in class, hopefully outside, to figure out why there's exactly 2 pi radians in a circle. Now that we have an idea of what a radian is, let's go ahead and compare a degree versus a radian. So degree versus radian. So let's say we start off with an angle of 30 degrees. So my initial side is going to be on the x-axis. My terminal side is going to be somewhere in the first quadrant. So this angle right here, let's just say is 30 degrees. So an angle that is 30 radians, so this angle over here that I'm about to draw is going to be 30 radians. I'm going to start with my initial side on the x-axis. So an angle that is 30 radians is going to look like this. So you almost have to go around the circle 5 times in order to get 30 radians. So based on this information, which one's bigger? Is a degree bigger than a radian, or vice versa? Is a radian bigger than a degree? If you said a radian was much larger, you were correct. So I'm going to just make a note of that. A radian is much larger than a degree. So let's think back when we defined actually what a radian was. Remember, we said there's 360 degrees in a circle, and then we said that there's 2 pi radians in a circle. This is going to help us fill out this conversion chart right here. So let's start with number 1. Pi radians is going to equal, well, if I get rid of this 2 right here, that means I would have to divide both sides by 2. So pi radians is going to be the same thing as 180 degrees. Now these next 2 are kind of just extra information. 1 degree is approximately, so this is an approximation, 0.017 radians. And 1 radian is approximately 57 degrees. Realize these last 2 are simply approximations. So let's get into what really is important. Let's say we want to convert degrees to radians. So I want to I'm starting off with degrees, and I want to end up with radians. So the first thing we're going to do is we're simply going to multiply by pi over 180. Alright, so let's take a look at an example. So let's say I had 45 degrees. Okay, so to be helpful, I'm just going to go ahead and write that over 1. And I'm going to multiply by pi over 180. Now you can do one of 2 things right here. You can simply cross cancel, or you can, when we multiply fractions, remember we simply multiply straight across. So if we do that, we would get 45 pi over 180. But we can't leave our answer in this form. We need to go ahead and simplify this. So you would have to say, okay, what does 45 and 180 have in common? They both have a 9 and a 5 in common, so it's going to reduce down to pi over 4. I'm actually going to show you a shortcut of how you could actually use your calculator to simplify this fraction for you if you're not the best at simplifying on your own. Now let's talk about the opposite. So we're going to start off in radians, and we want to end up with degrees. So we're simply going to multiply by the opposite. So this time we're going to multiply by 180 over pi. So let's look at an example. Let's say I had pi over 3 radians, and I want to convert that to degrees. So I'm simply going to multiply by 180 over pi equals, so notice right off the bat we can go ahead and cross cancel. The pi's are going to cancel each other, and I'm going to be left with 180 over 3, which will simplify to 60 degrees. And we're done. Alright, on your own, I want you to go ahead and try to complete the 6 problems below on your own. Alright, the last thing that we're going to talk about today are going to be coterminal angles. So first, what is a coterminal angle? Coterminal angles are 2 or more angles that share the same initial and terminal side. So for instance, let's say we'll stick with the 30-degree angle. So let's say I draw a 30-degree angle. Okay, so this angle right here is 30 degrees. A coterminal angle for 30 degrees, it's going to have the same initial, so it's still going to be on the x-axis. The terminal side is still going to be somewhere up in the first quadrant, except it's going to have a different numeric value to it. So if I draw this, notice I just went around the circle an extra time. So the coterminal angle would be 390 degrees. So looking at this, if I just go around the circle an additional time, to find coterminal angles, what do we have to do? So if I go around an extra time, we're simply adding or subtracting 360 degrees. So remember, it's really important. Coterminal angles, they're going to share the same initial and terminal side. They're just going to have a different numeric value assigned to them. So we just said to find coterminal angles, we're simply going to add or subtract 360 degrees. Because remember, we're just going around the circle an extra time. Now if we're in radians, we're going to add or subtract 2 pi. Because remember, there's 2 pi radians in a circle. So let's go ahead and look at an example of each. So let's say I'm given an angle of 100 degrees. I would ask you to find, for instance, one positive and one negative coterminal angle. So all we're going to do is take the original angle and add 360. If I add 360, I get 460 degrees. So this would be considered my positive coterminal. Now we also need to find a negative coterminal. So I'm going to start with my original angle, which was 100 degrees. Instead of adding 360, we're going to subtract 360. So if I subtract 360, I get negative 260. So this would be considered my negative coterminal angle. So this is the easier case. Where it gets a little bit more difficult is when we're working in radians. So let's take a look at that. So let's draw a line right here. Let's say my original angle is pi over 3. So I'm given pi over 3 radians, and I'm asked to find one positive and one negative coterminal angle. So this time I'm going to add 2 pi. So I'm going to take pi over 3 and add 2 pi. Now remember, to add or subtract fractions, we have to get a common denominator. So my common denominator is a 3, so that 2 pi is going to become 6 pi. And then if we add the numerators together, I'm going to get 7 pi over 3. So 7 pi over 3 is my positive coterminal angle. Now let's do the same thing for my negative. So I'm going to subtract 2 pi. Again, I have to get a common denominator. So I'm going to make the 3 the denominator, so that's going to become a 6 pi on top. So 1 minus 6 is going to give me negative 5 pi over 3. So my positive coterminal angle is 7 pi over 3. My negative coterminal angle is negative 5 pi over 3. Or subtract